In our previous lesson, we talked about trig, SOHCAHTOA, the sine being the opposite over the hypotenuse, the cosine being the adjacent over the hypotenuse, and the tangent being the opposite over the adjacent. We even talked about being able to find that angle measure if you knew two of the pieces of information. Today we're going to talk about using SOHCAHTOA to find the missing lengths of a right triangle. So you do have to know two things. You have to know one acute angle and you have to know the length of one side. And we're going to use our equations to set these up. So the first thing we're going to do is take a look at what we know. So we identify our angle of focus. And in this case, we have an x and a 10. So the x is on the hypotenuse. And the 10 is not on the side touching. That would be the adjacent. It's the one opposite. So we have hypotenuse and opposite. So if we look back up here at our trig fractions, which one uses opposite and hypotenuse? So I see an O and an H right here, so we want to use sine. So we're going to set up our equation as the sine. And remember I told you yesterday that the angle has to be situated right after sine, cosine, or tangent. And yesterday we put a letter there, but today I don't have a letter, but I do have its measure. So it's the sine of 40 degrees is equal to, and then we use our fraction, opposite over hypotenuse. So opposite is 10, and hypotenuse is x. So that's the first step. That's to write our equation. That's what that is. Now we need to solve that for x. So if I want to solve that for x, I need to get x out of the denominator. So I'm going to times by x on both sides. So now I have x times the sine of 40 degrees is equal to 10. Now I want to still get x by itself, so I need to get rid of times the sine of 40. So the opposite of timesing is dividing. So we're going to divide by the sine of 40. So these are going to cancel out. Now I have x equals 10 divided by the sine of 40 degrees. So what I want you to notice, because we'll use this from this point forward, is if the x is in the denominator like that, in order to solve in our calculator, all we're going to do is take the x and the trig statement and flip-flop them. So the x was down here, it went in front, and the trig statement that was in the front went to the bottom. So those two just flip-flop. Notice the 10 stayed right where it was. This only happens when x is in the denominator, so that's the only time we're going to use that shortcut. All right, so now we need to answer that. So we're going to grab our calculator and we're just going to type that in exactly as it shows. 10 divided by sine 40. Show my calculator screen a little better there. 10 divided by the sine of 40. I've just typed it in exactly as it said. Hit enter and we get 15.557. And it asked for the nearest tenth, which would be one number after. Since that's a 5, we're going to round that up to 15.6. Now keep in mind the hypotenuse is supposed to be the longest side, so we should get an answer that's bigger than the leg measure that we have, and 15.6 is bigger than that leg of 10. In part B, we have the same 40-degree angle, the same 10 over here, but now our x has moved here. So this is the hypotenuse. It has nothing marked on it, so I'm going to mark nothing. Over here I have a 10. That is on the opposite. And down here is the leg that is touching, so that would be the adjacent. So now I want to ask myself, which trig uses opposite and adjacent? So we go back up to this box up here. I'm looking for opposite and adjacent. Opposite hypotenuse, opposite adjacent. So here are the two letters I need, which tell me I need to use tangent. So our equation will be the tangent, and remember now I need an angle. I don't have its name, I have its measure. So the tangent of 40 degrees is opposite over adjacent. So 10 over x. And in the previous example, we talked about if the x is in the denominator, then we're going to flip-flop these two. So now we have x equals 10 over the tangent of 40 degrees. And that's what we're going to type into our calculator. So we take our calculator And we type in 10 divided by tangent 40 equals, and we get this 11.91. So 11 point, the 9, and the 1 after it does not round it up, so it's going to stay 0.9. And we get 11.9 as the length of that other leg. Moving on to the next example. We have an angle measure right here of 62 degrees. We have an x and an 18. The 18 is on the hypotenuse, right across from the 90-degree angle. And then 62 is touching this side where x is, so that means this is the adjacent. So we need adjacent and hypotenuse. So looking back up here, adjacent and hypotenuse, that shows up right in the middle. So we need the cosine. So to write our equation, we'll use the cosine 62 degrees equals adjacent over hypotenuse, so x over 18. X is not in the denominator, so we are not going to flip-flop these two. That wouldn't gain us anything. Remember, when you are solving an equation, it's your goal or your objective to get the x by itself. If I flip-flop these two, x is still not by itself. It would still have something under it. So if I want to get x by itself, I have to get rid of this over 18 right here. That means I need 2 times by 18. What I do to one side, I do to the other. So on this left side, I have 18 times the cosine of 62 degrees equals, and now dividing by x and timesing by x, they cancel out. That was the whole purpose. So now we just have x. There, x is by itself. So that's what we're going to type into our calculator. 18, oops, I'm not at the glare where you can't see, 18 times the cosine of 62. And we're going to hit enter, and we see 8.45. So 8.4, but then the 5, we'll round that up, so we're going to say 8.5. And that will be the length of this leg. Remember, legs are supposed to be shorter than the hypotenuse, so 8.5 is shorter than 18, so that works for us. And same triangle, 62 degrees, 18, but now our x is up here. So the 18 is still the hypotenuse. It's still the one that's across from the 90-degree angle. But now 62 doesn't touch where x is. This is the adjacent, remember, touching. The one that doesn't touch is our opposite. So which trig uses opposite and hypotenuse? So if we go back up to our little box, opposite and hypotenuse is right here, so we want to use sine for our equation. So the sine of 62 degrees, that's our angle, equals opposite over hypotenuse, so x over 18. It is our goal to get x by itself. X is not in the denominator, so we're not flip-flopping. That wouldn't gain us anything. We need to get the divided by 18 away from the x. So we will times by 18. What we do to one side, we do to the other. So I have 18 times the sine of 62 degrees equals, dividing by 18 and timesing by 18 cancel out, so we just have x. So now we have x alone. That means this is what we're going to type into our calculator screen. So we will do 18 times the sine of 62 degrees. Hit enter, and we get 15.893. So we want the 0.8, the 9 will make that go up. So 15.9 is approximately our value for x. Remember, your hypotenuse is supposed to be the longest, so we need a number that's smaller than 18, and we have one. That's just a good little check to make sure your answer even begins to make sense. All right, bottom row. So now we have a triangle where our angle of focus right down here is 25 degrees, and we have an x and a 20. So the hypotenuse is this one up here across from the 90-degree angle. There's nothing written on the hypotenuse, so I'm not going to identify it. The 20 is on the side down here that touches 25 degrees, so touching is adjacent. And then this X leg over here does not touch, so that will be our opposite. So we have opposite and adjacent. Looking back up at our top, opposite and adjacent is what we're looking for. That happens over here with tangent. So our equation will have tangent angle 25 degrees equals opposite over adjacent. So x over 20. X is not in the denominator, so we're not doing the flip-flop. We just need to get x alone, so we need to get rid of that over 20. So we will multiply by 20. What we do on one side, we do to the other. So 20 times the tangent of 25 degrees equals x. X is alone, so this is what we're going to type in our calculator in order to calculate x. So we'll type in 20 times tangent 25 equals, and we get 9.32, so that's not going to round up, it's going to stay 9.3 since the 2 is not 5 or bigger. So 9.3 is approximately the value for x, one of the other legs. One more example. So you'll notice this is a triangle very similar to the last one. We have our angle 25, we have a 20, but now our x is up here. So across from the 90-degree angle will be our hypotenuse, and the 20 is touching 25, so that's going to be our adjacent. So the trig that uses adjacent and hypotenuse, if we look back up here, adjacent and hypotenuse belong to cosine. So our equation should have the cosine of 25 degrees is equal to, and it's adjacent over hypotenuse. So 20 over x. Now x is in the denominator, so this is when we do the flip-flop. So we switch the x and the trig statement. So x equals 20 over the cosine of 25 degrees. Notice the 20 stayed right where it was in the numerator. The only thing we flip-flopped was the x and the trig statement. Now x is alone, so this is what we'll type into our calculator. So we will do 20 divided by the cosine of 25. Hit enter. We get 22.06. So that 0 is going to round up since 6 is 5 or bigger. So 22.1 appears to be our approximate value, and that was supposed to be a hypotenuse, so it should be longer than the other two legs, and it is. It's longer than 20 and it's longer than 9.3. So we know that our answer at least makes sense in our context. Tomorrow we're going to look at word problems, but today we're just going to stop there and focus on solving for the lengths of individual triangles that have an acute angle and one side length known.